Good morning. My name's Jane Barnett, and in this project, we've looked at some effective ways to detect and respond to misconceptions that persist after teaching.
Leighton Sixth Form College is located within the London Borough of Waltham Forest in East London. There are just over 2,000 students enrolled at the college. Around half live within the borough and the remaining are from neighbouring boroughs. The college offers a broad range of vocational and academic courses. Most students study at level 3, and there are also some students studying BTEC level 1 and 2 and some students studying on the ESOL course. All students at the college with a GCSE maths grade of less than 4 are enrolled on a GCSE resit class. There are two types of GCSE resit classes. Students with grades 0 to 2 are in a 2-year foundation GCSE class with an opportunity to take the exam at the end of year 1. This is to track progress and improve their grade. The second group of students are enrolled onto a GCSE Foundation Plus class, and these students have already a grade 3 in maths. Students are expected to get a grade 4 within 1 year. Currently, all GCSE Maths students have 4 hours per week of timetabled GCSE Maths lessons. Leighton Sixth Form College is a centre for excellence in GCSE Maths. At Leighton Sixth Form College, we have focused on incorporating mastery learning into the GCSE Maths schemes of work. We have chosen a smaller selection of topics to allow time to master core concepts and skills in depth. These have been put together into units to show the connections between them. We have collaboratively planned lessons to support the mastery learning for each unit. We have made use of the end of unit tests, which were designed using the Diagnostic Questions website to rapidly diagnose misconceptions that are still present after teaching. The end of unit tests were designed in a way that gave us quite clear ideas on whether the concept was secure or not and which type of misconceptions were still present. Our scheme of work was designed with some prior research into the topics that appear in past exam papers. We looked at the frequency of appearance of each topic and grouped them into areas of focus. Here is how our scheme of work looked for autumn term 2 and spring term 1. In this action research project, we chose 3 areas of the scheme of work to focus on. The first cycle of our research was focused around area and volume. For cycle 2, we concentrated on powers and roots, and for cycle 3, we concentrated on sequences and graphs. This type of scheme of work gave us the freedom to adjust our teaching by checking how secure a concept was before moving on.
We did quite a lot of reading for this project. We started by researching really efficient ways to identify the misconceptions the students have. And then we looked at how you might address them. There's a couple of different models. Julia Smith used whole class discussion, and Dylan Williams recommends doing it through discussion in small groups. We focused on small group and pair discussions. The book that really inspired this project is Harry Fletcher Wood's book, Responsive Teaching, which I really recommend that you read. And we did some reading about how to manage students' likely emotional responses to addressing their own misconceptions.
Okay, so as previously mentioned, we've moved to using diagnostic questions as end of unit checks at the end of teaching each topic. As we worked on the project, after each of the end of unit checks for our particular topics we were looking at, we went through and identified the most common misconceptions for each class. We then looked at the best way of giving feedback to the students to try and undo the most persistent misconceptions we could see. As we developed this in cycles 2 and 3, we particularly used anonymous student work to help them discuss those misconceptions and work on their feedback.
Hi, my name is Joanna and I am one of the members of the Action Research team at Leighton Sixth Form College, and I will be talking to you about student conversations and explanations given for each cycle. So for cycle 1, we focused on area and volume, and here's an example of a multiple choice question we gave the students. One student was able to recognize the misconception and wrote careful notes of how to answer this volume question. So they said, I need to do 6 times 8, and that's 48. And then I do 48 divided by 2, which is 24. And then I do 24 times 12. Now, when the teacher asked them, what they had done differently than before, the student explained that they usually would do 6 times 8 times 12, and not remembering to divide by 2 because it was a triangle. In cycle 2, we focused mainly on powers and roots, and here's an example of a student conversation that took place. There was 2 students that were arguing about who was correct. And one of the students said 2p cubed to the power of 4 is equal to 8p to the power of 12. And the other one said 2p cubed to the power of 4 is equal to 16p to the power of 12. And they're both arguing about the fact that they both felt that they were right. The first student explained that everything in the bracket is multiplied by 4. The second student clarified and explained everything inside the bracket is being multiplied by itself 4 times, which convinced the first student. And here's some commentary here. This 4 means you do 2 times 2 times 2 times 2. And the student said, oh yeah, okay. In the final cycle, we focused on sequences and graphs. So here we have an example of a question that we gave a student with an explanation and the selection of A, being 2n minus 3. And the student had to write down whether they believed the student was correct or what they could have done differently. So this student said you should always start by timesing the first term both by 1. And they showed this underneath the selection B, where it says 2 times 2 plus 3 equals 7, 2 times 1 plus 3 equals 6. Now, although they were wrong, they recognized that the 7 was the second term. So they believed that 2n plus 3 was the correct answer. They also said here that this means the sequence starts with 2n. Check the first term as an explanation of what you could do if you got an nth term question again. So this explanation was pretty good. The second explanation here was from a student who normally would finding the nth term quite difficult, and they were able to find the nth term, and not only that, but also answer the second question, equating it to 90 and solving and recognizing that because it's not a whole number, 90 is not in the sequence.
In the last part of our project, we looked closely at the longer-term impact of responsive teaching on the intervention groups. We did that in 2 ways. Firstly, we looked at these students' responses on mock exams, and secondly, we created a shadow test covering all of the topics in all cycles. These shadow tests were designed in the same way as the end-of-unit test, with an explanation box as well. So here is an example of the end-of-unit test, and for example, this question, the students had lots of misconceptions, and so we did the teaching on this topic, and the responsive teaching was to tackle some of these misconceptions. And then after that, in their mock exam, we looked at this question, and it was a bit more challenging, obviously, and we found that 21 out of 33 students attempted it, and 17 of them demonstrated they could use the formula for area of a triangle correctly. So it seems like some of this intervention has worked on those students, because the students that were having trouble with this kind of question eventually were able to get a good mark on their mock exam. So here's an example of a question from cycle 2. So on the left hand side we have the end of unit test question where students mostly got it wrong. They thought that the coefficient would be multiplied by the power outside the bracket, and only 20% of the students got this question correct. On the right hand side we've got the shadow question, which is very similar to the initial end of unit test question. So on the shadow question, when we tested this later on in May, about 1 in 3 students got this correct. So it shows some progress, and the intervention did help. So here is an example from cycle 3. On the left, we have the end of unit test for graphs, and on the right, we have the shadow test. And the shadow test is very similar to the end of unit test. So on the end of unit test, we found that nearly all students picked an equation that started with y equals just because it is parallel to the y-axis. Also, students were not even recognizing that the number associated should be a negative number. When we did this in late May with the shadow test, around half the students got this question right. And also, nearly every single student was recognizing that it should actually be a negative number there. So whether they chose it to be y equals or x equals, at least they recognized that the number associated should be a negative number.
We had lots of information about sequences because it came later on. So we saw on the mock that about 1 in 3 of them knew how to get the nth term of the sequences, and the students who weren't successful with this were getting the common difference, but they weren't getting the intercept. So after teaching sequences, we gave them this multiple choice question on their end of unit test, and we saw that they did know to get the intercept, but that they were mixing up which way round it went in the formula. So we did a 20 to 30 minute classroom pair discussion, and after that, nearly 2/3 of them could do it. Now that's not as many as I want. I want everyone to be able to do this, but it's noticeable that this 20-minute intervention made nearly as much difference as a 2-hour teacher-taught lesson.
So it's not a magic bullet, but it is a really efficient use of class time. So instead of having to teach sequences all over again, you do this 20-minute review and you're ready to go on to problem solving. You could do it with any kind of assessment. So if your college uses like set assessments, you could take this approach with any assessment, pick a focus question, produce some wrong work and get them to discuss it. But we do recommend multiple choice questions because they're really efficient at identifying what the particular misconception is. The pairs seems to be important. They're much more likely to speak and listen when they're working in pairs. And the anonymous work is really important. People are much more comfortable talking about someone else's mistakes than their own. And their feedback is much better. When they're giving it to somebody else, they're much kinder with their feedback when it's for somebody else. You do need to explicitly teach students how to give good feedback. It's a skill, they don't automatically have it. But once they do know how to give feedback, you can use some of that time that you were spending on teaching them to give feedback to pivot into building on that knowledge that they've just prepared. And that's thank you for your patience with the technical issues.